Hello friends, welcome to my channel Master the Monster. Equations. Do you think equations are pure mathematics? Then you're absolutely wrong. Equations are part of our daily life. We use equations in our daily life. We not only use them, we also need equations to solve many real life problems. Before learning equations in detail, subscribe to my channel so that you will enjoy learning maths. 3.3 problem number 3. The first 3 sections I have already solved it in the previous video. If you haven't watched and you can go to the description box and the link is there, you can have a look at it and then proceed to this. Here we will deal about the 4, 5 and 6 subdivisions of problem number 3 of exercise 3.3. Okay. Now we'll start with the fourth subdivision. Given the taxi charges in a city consist of fixed charge together with the charge of the distance covered. That is, in a city, if you have to use a taxi means you have to pay two charges. The one is the fixed charge, just like rent. Okay, and then is the charge per kilometer. Charge for distance covered. So if you want to take a taxi, then you have to pay both these charges. Okay, and the problem is to find the fixed charge and the charge per kilometer. So let me assume that the fixed charge be, let the fixed charge be rupee X and the charge for distance covered be rupee Y per kilometer. Okay, for 1 kilometer you have to pay Y rupees. For 2 kilometers means you have to pay 2 Y rupees. 5 kilometers 5 Y rupees, like that, right? Okay, so both the charges we are going to pay. Now we'll see the conditions given. For a distance of 10 kilometers. So somebody have traveled 10 kilometers and he paid 105 rupees. So somebody has taken the taxi, isn't it? So first he should pay the fixed charge. So he should definitely pay X. Okay. Then he should pay the charge for 1 kilometer. The charge for 1 kilometer is Y and he has gone 10 kilometers. So the charge is 10Y. So he should pay both the charges. So X plus 10Y. Both he should pay, and that amount is given as 105. So this is my first equation. X plus 10Y equal 105. Then it's given for a journey of 15 kilometer and somebody else has traveled 15 kilometer and he has paid 155 rupees. So this person will pay the fixed charge first. So X he will pay. Then he traveled 15 kilometers means he will pay 15Y. So together he should pay both the charges and that cost him 155. This is my second equation. So this is how we got the equations. Do you understand? Okay. Now we are asked to find the fixed charge and charge per kilometer. So we are going to find X and Y using substitution method. And also you are asked to find how much does a person have to pay for traveling a distance of 25 kilometers. So something is also asked in the problem. We'll come to that later. First let me solve these two equations and get X and Y, that is the fixed charge and the charge for 1 kilometer. Let me find out. Then we'll go for the next section of the problem. Right? Consider the first equation can express one variable in terms of another. Okay, so let me take X equal 105 minus 10Y and let me substitute. Let me take this third equation and let me substitute 3 in equation 2. So I get 105 minus 10Y plus 15Y equal 155. Now we'll combine the variables and the constants. So 15Y minus 10Y is 5Y equal 155 minus 105, that is 50. So Y equal 50 by 5, that is 10. Okay, so the charge per kilometer is 10 rupees. Now we'll go for x. We'll go to third equation. So substitute y equal 10 in equation 3. So I get x equal 105 minus 10 into 10. So it's 105 minus 100, that is 5. So x equal 5. So we have got the fixed charge. The fixed charge is 5 rupees. Okay, so if you want to take the taxi, you should pay 5 rupees definitely. Fixed charge. Okay, and then the charge per kilometer. The charge per kilometer is rupees 10. So if you want to travel 1 kilometer, you should pay 10 rupees. 5 kilometers, 50 rupees like that. Alright, so this is how we have found the fixed charge and charge per kilometer. So the first part of the problem is over. The next is that how much does a person have to pay for traveling 25 kilometers. Now we'll see the charge for traveling 25 kilometers. Okay, whatever be the kilometer, first you should pay x rupees, isn't it? And then you have to pay y rupees for 1 kilometer. Now it's 25 kilometers, so it's 25 into y. So the charge for traveling 25 kilometers is x plus 25y. So this is equal to x here is 5 plus 25 into y is 10. So it's 5 plus 250, that is 255. Therefore, a person has to pay 255 rupees to travel 25 kilometers. Hope you all understand. Thank you. Okay, fifth subdivision. A fraction becomes 9 by 11 if 2 is added to both numerator and denominator. If 3 is added to both numerator and denominator, it becomes 5 by 6. Find the fraction. So here the problem is about a fraction. You are asked to find a fraction. So you will very well know that a fraction is going to have numerator and denominator, isn't it? And of course numerator by denominator. So let me take the numerator as x and the denominator as y. Then the fraction is going to be, therefore the fraction is x by y, isn't it? Where x is the numerator and y is the denominator. So the fraction will be x by y. Now it's given we are adding 2 to both numerator and denominator. So the numerator I add 2 and to the denominator we add 2. So that the fraction becomes 9 by 11. This is equal to 9 by 11. So this is the first condition given. When you add 2 to both numerator and denominator, the fraction becomes 9 by 11. Now let me simplify this first to get the first equation, right? So this is given. Now let me simplify so that I cross multiply this 11 and y plus 2. So we get 11 into x plus 2 equal 9 into y plus 2. Now let me multiply so that I get 11x plus 22 equal 9y plus 18. Let me group the variables. 11x minus 9y equal 18 minus 22. That gives 11x minus 9y equal minus 4. So this is the first equation. Now one more condition given in the problem is given if 3 is added to both numerator and denominator. So we are going to add 3 to both the numerator and denominator. So I'll add 3 to x as well as y. Then the fraction becomes 5 by 6. So the fraction is equal to 5 by 6. So this is our second condition given. Now we'll simplify this to get the second equation. So that I get 6 into x plus 3 equal 5 into y plus 3. So 6x plus 18 equal 5y plus 15. So 6x minus 5y is equal 15 minus 18. That gives me 6x minus 5y equal minus 3. Let me mark it as equation number 2. These are the two equations we have obtained. Now we will solve these equations by substitution method, right? From equation 1, let's try to rearrange this equation as 11x equal minus 4 plus 9y. So that I write x equal, we can take the positive term first. So 9y minus 4 divided by 11. So this is my third equation. That is, I have expressed x in terms of y. Now let me substitute this third equation in second equation. So substitute 3 in 2. So that we get 6 into 9y minus 4 divided by 11 minus 5y equal minus 3. Okay, now let's multiply throughout by 11 so that I get 6 into 9y minus 4 minus 55y equal minus 33. Now also we'll multiply the 6 inside, therefore we get 54y minus 24 minus 55y equal minus 33. So here we'll combine the variables and then the constants. Okay, so when we combine the variables, it's minus y equal minus 33 plus 24. So I get this to be minus 9. Therefore y equal 9. So we have got the denominator as y equal 9. Now let me substitute this y equal to 9 in the third equation. So substitute y equal 9 in third equation so that we will get the value of x. So x equal 9 into 9 minus 4 by 11. So this is 81 minus 4 by 11, that is 77 by 11. That gives me x equals 7. So we have assumed that x is the numerator and y is the denominator. Therefore, we have got the solution. The solution is, the required fraction is x by y, isn't it? That is 7 by 9. So the answer is 7 by 9. Let's check the conditions given. See, 7 by 9 is, the fraction is x by y. Now we have got the answer as 7 by 9. So the first condition is when you add 2 to both numerator and denominator. So you add 2 to both numerator and denominator. So when you add 2, you get 9 by 11. So that's correct. Okay. And then the next condition is add 3. So when you add 3, you get 10 by 12, which on simplification gives 5 by 6. So the second condition is also true. So we have found the fraction and also verified whether the answer is right or not with the given conditions, right? Final one is the age problem, right? The familiar problem. We have already dealt with this such type of problem in our previous exercise. Okay. We are given 5 years hence age of Jacob will be 3 times that of his son. 5 years ago Jacob's age was 7 times that of his son. What are their present ages? So always we'll assume their present ages as x and y, isn't it? So let's start with the assumption. Now the first condition given us 5 years hence. 5 years hence means after 5 years. Jacob will be 3 times old as his son. So Jacob is x plus 5 and his son is y plus 5 after 5 years. And Jacob is going to be 3 times his old as his son, means it will be 3 into y plus 5. So this is our first relation. This on simplification is gonna give me x plus 5 equal 3y plus 15. So I can say x equal 3y plus 15 minus 5, that is x equal 3y plus 10. Otherwise I can say x minus 3y equal 10. Whatever be the equation, you can name it as equation number 1. Okay, either x equal 3, because we are going to do only substitution method. So I can first itself express x in terms of what? The next condition given is 5 years ago. Jacob's age was 7 times that of his son. So 5 years ago, Jacob is x minus 5 and his son is y minus 5. And Jacob is 7 times his son's age. So it is x minus 5 equals 7 into y minus 5 is our next relation. Now let me simplify this again. So x minus 5 equal 7y minus 35. Otherwise I can say x equals 7y minus 30, or x minus 7y equal minus 30. Whatever be the second equation, you can take it. So this is equation 2. Okay, now let me substitute equation 1 in equation 2. So this is my equation 1. So I'll substitute it in equation 2. I can take any one of the equations. So I'm going to take this equation as equation 1 and this equation as equation 2. So let me substitute equation 1 in 2 so that I get 3y plus 10 equals 7y minus 30. Let's group y to one side and constants to the other side so that I get 7y minus 3y equal 10 plus 30. Alright, so I get 4y equal 40. That gives me y equal 10. So we have found the son's age. It's 10. He is 10 years old. Now let me substitute y equal 10 in equation 1. Equation 1 is x equal 3y. So it's 3 into 10 plus 10. That is 30 plus 10. That gives x equal 40. So we have got x equal 40 and y equal 10. We have assumed that x is present age of Jacob and y is present age of son, isn't it? Therefore, I can write the present ages. The present age of Jacob is 40 years and that of his son is 10 years. So at present Jacob is 40 years old and his son is 10 years old. So this is how we have formulated all the situations into equations and also found their solution by substitution method. Hope you all understand. So this is all about problem number 3 of exercise 3.3. Thank you.